Welcome! In this video, we are going to determine if lines are parallel, perpendicular, or neither. So let's go ahead and take a look. So we've already learned that if lines are parallel, so if we have parallel lines, then we know that they have the same slope. If lines are perpendicular, we know that the slopes are opposite and reciprocals. So opposite reciprocal slopes. So if I give you two equations, and if we have to determine if they're parallel, perpendicular, or neither, and when I say neither, it means they're not parallel and they're not perpendicular. So if I give you two equations, 3y minus 2x equals 12, and 6y equals 4x plus 6, I want to find if these lines are parallel, perpendicular, or neither. So the very first thing we're going to do is we are going to put it into slope-intercept form. And the reason why I want to put it into slope-intercept form is because from there, it's going to be easy for me to identify the slopes of those lines. So let's take a look at the first one. 3y minus 2x equals 12. Remember, slope-intercept form is y equals mx plus b. So I want to go ahead and get y by itself. So the first thing I'm going to do is add 2x to both sides, which means 3y equals 2x plus 12. And then I'm going to divide both sides by 3. So y is going to equal 2/3 x plus 4. So the slope of this equation is the number in front of x, which will be 2/3. So I'm just going to go ahead and circle that. Then I'm going to find slope-intercept form for my second equation. So my second equation was 6y equals 4x plus 6. I'm going to go ahead and divide both sides by 6. So I end up with y equals 4 over 6. Well, I can reduce that fraction because 2 goes into both of them. And 2 goes into 4 2 times. And 2 goes into 6 3 times. So I get 2/3 x plus 1. And if I look for my slope, which is right in front of my x, I get 2/3. So in this situation, both my slopes were 2/3. So since they have the same slope, that means that these lines are parallel. Okay, let's take a look at another one. I want you to determine if these lines are parallel, perpendicular, or neither. Go ahead and pause the video, and when you're done, come back and let's see how you did. Welcome back. All right, let's check to see how you did. That first equation I do not need to put in slope-intercept form because it's already in slope-intercept form. Y equals 2x plus 4. So if I circle my slope there is 2. Let's look at my second equation. So it's 2y plus x equals 6. I'm going to go ahead and get y by itself by subtracting x from both sides. So I end up with 2y equals negative x plus 6. Divide everything by 2. So I get y equals, I'm going to rewrite that negative x over 2 as negative 1/2 times x plus 3. And if I look at my slope is a negative 1/2. So I have a slope of 2 and I have a slope of negative 1/2. Well, first of all, they're not the same, so I know they're not parallel. For the 2, this one's positive and this one right here is negative, so I know that they're opposite. And then reciprocals, where the reciprocal of 2 would be 1 over 2, so they are opposite reciprocals. Which means that these lines are perpendicular. All right, let's take a look at one last example. So again, I want you to determine if these lines are parallel, perpendicular, or neither. Go ahead and try this. Pause the video, and when you're done, come back and let's see how you did. Welcome back. All right, let's check this out. So for the first one, I have 4x plus 3 is equal to 3y. Y is almost by itself. I'm going to go ahead and divide everything by 3. So I get 4/3 x plus 1 is equal to y. My slope here is 4/3. Let's look at my second equation. So 8y minus 6x equals negative 16. I'm going to add 6x to both sides. So 8y is equal to 6x minus 16. Divide both sides by 8. And I will end up with y equals, if I reduce the fraction 6 over 8, that reduces to 3 over 4 x minus 2. So my slope there is 3/4. So I'm looking at 4/3 and 3/4. They are reciprocals, because the reciprocal of 4/3 would be 3 over 4. However, they are not opposite. They are both positive. And in order for it to be perpendicular, one would have to be positive and the other negative. So since they're not the same, and they're not perpendicular, the same meaning they're not parallel or they're not perpendicular, then I know that these lines are neither. So there you go. There's our lesson on parallel perpendicular lines. Go ahead and move on to the next part of this session.